here we have a beam waste analyzer monitor, and so I'll explain basically what it does. I mean, we're analyzing the focus spot of the laser beam and some of the key parameters that people are interested in for the laser beam. So this little image here shows a graphic of a focused laser beam, and we create spatial time slices through this focus, and we do this with a passive optical design so that we're looking at all these spatial slices in one image. The traditional systems used for this, you always have moving parts, and with that they're a little harder to set up, they take more time, and you don't get real-time measurements. With this instrument, everything is in real time, so it's instantaneous information. So here we have a graphic of what the optics look like. You have a laser beam coming in, which is this component here, a focusing lens, which is right here, and then we have this, the heart of the system, this Fabry-Perot Etalon pair, which is at this location. And this is what takes and splits the beam up into these multiple spatial time slices that allow us to easily find the focus and beam waste size of the beam. And then, of course, that's all imaged on this sensor back here. So, although we have a milliwatt laser in here, this same system can do multi-kilowatts. We've installed systems up to 30 kilowatts in CW laser power, which is a tremendous amount of power. So it's just a question of changing this module to attenuate for the higher powers. But it's a very straightforward system, and I'm going to quickly switch screens. So here, this is a live screen of the measurement of the laser. So here we have our focused beam waste. And then in order to make the measurement, you've got to get some spots beyond the second Rayleigh range, which is this region, and that's what this is here. So here we display all your parameters of the beam, the m² value, also interest to many industrial customers, beam parameter product. The two numbers are very closely related, just a different set of units. And you as well can use this like a beam profiler. So here we see our spatial time slices of the beam, and we can zoom in. So here we see an enlargement of the beams. And so the primary advantages of our system is it's real time. That means even for a single laser pulse, you can get an m² measurement. There's no other system on the market that can do that. Secondly, with the really high power lasers, what you find is there's thermal lensing that occurs, and this system will track that thermal lensing, which other systems on the market are unable to do. And this can be configured in many, many different arrangements to accommodate a wide variety of setups. I'm going to move to this slide. So for high volume laser production, we have an automated system. For more general laboratory use, we've got this tabletop unit, a little lower cost, but still very, very precise. We have inline monitoring, so you can monitor in real time while you're processing. And then, of course, just the basic camera. So all different applications can be accommodated by just swapping of some modules to accommodate low powers, high powers, many different focusing setups, and so forth. So lots of versatility and capability with this product. So I guess at this point I'm open to ask or answer any questions that you may have on this very unique product.
The good thing here is that you're almost not limited by the power.
That's right.
From milliwatts to kilowatts.
Kilowatts, yeah, it's pretty amazing.
So this is quite unique, and it's one of the few products that I know that you can have customers in the laser diodes all the way to the excimer laser.
That is correct, yes, yes.
What is the key market application for this particular laser component?
Well, there's really two. Laser manufacturers will be one, because when they're making lasers, they have to measure the laser's m². So that's the sort of the easy one. But then industrial users, although they may not necessarily be interested in the m² number, I mean, it's important, but what they're interested in is, what does my laser beam look like at my focus? Yes. Okay, that's what they're interested in. And is it changing over time? So because in processing, the stability of the laser beam is very important. So knowing what it's doing while they're processing is extremely valuable.
One of the things I always like for laser components is that you are very product oriented, but you are a solution solver.
Yeah.
When I talk to some of the laser integrators, many of them they are telling me the biggest challenge we have today is the beam shape. The beam shaping for the welding and for the beam shaping for the cutting. What solutions do you have for beam shaping and laser components?
Well, for beam shaping, I mean, there's many different, like over here, there's diffractive optical elements. There's more traditional optical approaches like lens arrays. So there's a lot in freeform optics. So there's many different solutions. And but although you may have this solution, you have to measure it, and that's what this product will do. So whether you've got a simple Gaussian beam or some complex homogenized line beam or whatever shape, you know, we have the tools to create the shape or to measure the shape, and both are important.
If I had to ask, this laser industry more and more is coming to Europe. I can see the companies like Trumpf every year growing and integrating more laser components from Europe, but there is also companies in Asia like Hans Lasers or Max Photonics really are pushing like that. Could you tell me a bit, for laser components, are you purely focused on the German market, or how does the Asian market look like today and in the future in your opinion?
Okay, well, Laser Components is a worldwide distributor of optics, so pretty much, you know, the world is the stage for laser components. So wherever there's a need for optical components used for lasers, we're there to serve.
Thank you very much for a great presentation. I'm a really big fan of the company, as you can maybe notice. I have been to visit you in the location in Munich, and I plan to visit you also in many of your 7 locations, 8 locations that you have worldwide. So I will keep doing that. Thank you for your time, Mike.
Okay, it was a pleasure. Thank you.